Hey folks, I think I'm back. I'm still having a few issues though, so I apologize. I'm trying to work this out. Um, Let me see. Let me see if this. All right, I'm gonna try this. If it seems to have issues, I might need to restart my computer. Let me just orient myself with where I am. All right. Okay, it's a little slow, but I think it's a little bit faster than it was, so not quite sure what's going on, but hopefully it'll hold up for me. All right, I'm gonna go ahead and get started. And just as a reminder, if you are watching live, feel free to chat with me as I'm doing this. All right, so this is the data visualization section of my course. Let's see, and so I'm gonna start out, I'm just actually orienting myself because it's been a little bit since I did this. So I'll talk about an overview, and I've kind of framed this around the idea of using best practices for data visualization. I thought about just kind of having it take a more like cookbook type approach where it just focuses on very specific things. You know, this is how you do this is how you do that, but I thought it would be better to really orient it around the idea of best practices and applying those to R. So I'm actually going to use this data visualization from John Murdoch of the Financial Times. This is an early version of the coronavirus trajectory chart. You can see it is from, when is it from? March 11th. And so, you know, obviously it's changed significantly since then, but this is kind of when it really started to take off. And the nice thing is, actually, this was the ggplot code that John Murdoch used to make this. He posted it online, so I'm actually going to use that as an example. So I'll talk about kind of the overview. Yeah, all right. Let me go ahead and get started. Welcome to the Advanced Data Visualization section of the course. In this section, you're going to learn how to make your plots made with ggplot look really good and really professional, and the types of things that you'd want to share with an audience to communicate effectively. I've framed this section of the course around best practices in data visualization. So in other words, I'm not just telling you, hey, do this, do that, here's a recipe to do this. I actually want us to take a step back and think about, well, what are the best practices in data visualization, and how can we apply those in R and specifically within ggplot to make effective visualizations that will really communicate well to our audience. You may recognize this visualization. It was done by John Byrne Murdoch of the Financial Times. It was showing the trajectory of the coronavirus spread. And this is from March 11th. This is an early version. I'm recording this on April 28th. So this is about a month and a half ago, and obviously this has changed. But it's, this visualization has continued to be updated. And I'm using this as an example that we'll refer back to throughout this section of the course because I think it does several things really well. And I'll talk about what those things are in just a minute. And the other reason we're going to use this is actually you can check out the code. John Byrne Murdoch produced the early versions of this visualization using ggplot, and he posted the code. So you can refer back to that to see how he made this, which is really cool. So the thing that I like, there's several things that I think are best practices within data visualization and that John Byrne Murdoch's work does, is it highlights, first of all. Actually, you know what? I'm going to flip back here. So I'm talking about kind of each of these things: highlight, declutter, explain, and sparkle. I think what I'm going to do actually is after each of them, just add a slide that goes back to the visualization itself, so I can then like highlight, okay, well, what is it that, how does the visualization highlight well, that type of thing. All right, whoops, I'm gonna knit this again, make my slides. Okay. While I'm waiting for this to knit, if you're watching live, I'm curious to know kind of who you are and where you're watching from. I like to always ask that, and I'm just curious. So feel free to put that in the chat. Oh boy, this is knitting slowly. I know I could cache. Hold on, let me actually. So I set cache to true. Hopefully that will make things work more quickly when I knit in the future. We'll see. I think this is especially taking a while because it's making a bunch of data visualizations. So. Okay. Okay. All right, so I'll start on the highlight section. Highlight. Then. All right. So one thing that I really like that this visualization does is it highlights the findings really well. Let's talk about how it does that. So I think it does it in a few different ways. First of all, it has a really clear title, and it has a title that actually describes what's going on. It doesn't just say coronavirus trajectory over time for the title, kind of generic title that I think many of us are used to seeing. It actually tells us most Western countries are on the same coronavirus trajectory. Hong Kong and Singapore have managed to slow the spread, right? It's telling us what we need to know. It also highlights findings in a couple ways in the chart itself. So it uses color really effectively, I think, to highlight. And the other thing it does is it uses text annotation. So for example, South Korea here, and then it actually talks, it not only shows South Korea directly labeled here, but then it actually talks about what's happening in South Korea directly on the chart. Uses annotations really effectively. I think this visualization is also effective because it's not cluttered. So decluttering is a really important part of data visualization. By decluttering, by taking out what's not necessary, we can really highlight the findings. So if you look at the decluttering here, I think you can see that through the minimal grid lines. The grid lines are only at the major breakpoints, not at the minor breakpoints, which we'll talk about. It also is decluttered. I'm just thinking. It's also decluttered because it doesn't, if you notice, have a title on the y-axis because it's really clear through the title and subtitle what that y-axis is, which is to say it's coronavirus cases, right? So we don't need it. It's redundant. We're removing anything that's not necessary. It also explains really well. And as we mentioned before, it does that with a really effective title as well as with annotations. And so we'll talk about using both of those within ggplot. And then finally, it sparkles. And I think of sparkle as just kind of like putting like minor touches on things that make things really look nice and communicate effectively. So I think it does that by using, for example, custom fonts. I don't actually know what the font is that they're using here, although we could pretty easily figure it out. But it doesn't use the default font. It also does not use a default theme. So if you see plots made with the ggplot default theme that have that kind of gray background, you can pretty quickly identify, oh, that's a ggplot. But this has a very distinct look that screams Financial Times. So I think those are a couple ways that this chart, this visualization really sparkles. All right, I'm going to stop my recording and then start it back up again. Okay. All right. So the next section, give me 1 second. I'm going to let my dog go out of this room. Diego, out. All right. So the next section, I actually want to return to the idea of tidy data. And actually, I'm just thinking, because I don't actually have a my turn or your turn in that last one. That's fine. It doesn't need an exercise for folks. I'm just thinking this one actually probably won't have an exercise either. Just thinking through this. Okay. I think just the first little bit's not going to have exercises until we get to the piping data in. Yeah. All right. So I want to return now to the idea of tidy data, which we talked about in the data wrangling and analysis section. But it becomes important, and I'd say actually this is where I first really realized the importance of tidy data. Tidy data is particularly important for ggplot. In fact, in order to make visualizations using ggplot, your data has to be in the tidy format. Let me give you an example where data is not in a tidy format and show you why it's problematic. So take a look at this data. I'm importing this kind of German speakers data. I'm getting rid of any NAs you can see there in the read Excel function, and then using clean names. So our data looks like this. We've got state and then number of German speakers. I could scroll through and see, all the various states. And then I have three, in addition to the state, I have number of German speakers 2017, number of German speakers 2018, and 2019. And as a reminder, this data is not tidy because, for example, within this variable, number of German speakers 2017, there are multiple things going on, right? So we have number of German speakers as well as the year. And we need each column to be a single variable. And because it's actually showing two things, again, number of German speakers and the year, it is not tidy. Okay, so let's take a look at what happens if we want to plot this. Thinking about how I would plot this, if I wanted to make like a bar chart to show the number of, hold on, I'm just thinking if I want to, okay, let me just start recording here. So let's think about what it would look like if we wanted to plot this and we have untidy data, right? So I can do ggplot, I just list what my data is, my mapping of aesthetics. So say I want to put on the x-axis, I want to put the state. What would I put on my y-axis, right? Would it be this first variable? Well, I could if I wanted to just show 2017. But then what if I wanted to do a small multiple chart that showed 2018 and 2019? I can't actually do it using the data in the format that it's in right now because there's no single variable that I can put for my y. And so as a result, we can't plot in the way that we want to. If I take that data that I've imported and I make a new data frame called German speakers tidy, I'm doing some pivoting here, and I'm not going to walk through the details, but just it'll be really similar to what we did before. Let's say I end up with this data now. So we have state, Alabama, year 2017, 2018, 2019, and this will look really familiar, right, from the last section. Okay. Now I can plot this because I can put in my y, I can put the state. And so then I can make a bar chart, for example, and I can use facet wrap for year. So in other words, I can make small multiples, one chart for 2017, one for 2018, one for 2019. And I can do that because my state, I'm just thinking, this is kind of backwards because here I have state in the X. Hold on, I should make this consistent. All right, let me knit that. Let me see if this hopefully knits a little bit more quickly. Oh, it's still going slow again. Hopefully after this time it'll knit faster because it'll be cached. Sorry, folks. I know it's taken a little while to knit. I'm really hopeful that the caching will make it go faster from here on out. Caching is just a nice way. Someone can correct me if I'm misinterpreting this, but when you set in your R Markdown, in your options, cache equals true. What that does is any code chunks that don't change from one time when you knit it to the next time, the R Markdown knows, okay, I don't need to kind of rerun that code. I just use the cached version of it, which is nice. Just FYI, if you're wondering like what's this setup.rmd, I have just created a separate child R Markdown document where I list out all my options. And then it also actually has the this at the bottom, and it does that for, I do it separately so I can set it automatically for all of my slides. All right, let me go back here. Actually, just while I'm thinking about it, just try and like reknit this and see. It should ideally go faster now. Yeah, I think it is going much faster. Okay, perfect. I don't know why I didn't have that set up before. Okay. All right. So let's try to think about plotting this data. What if we wanted to make, for example, a small multiples bar chart that showed the number of German speakers in each year, 2017, 2018, 2019, as its own small multiples bar chart? How would I do this? Well, just starting out with the code to start my ggplot, I don't even know what variables I would put, right? Like I could put on the Y, I could put state, so there would be bars there, and each state would be on its, on the Y axis. But what would I put on the X axis, right? Like I could put number of German speakers 2017, that variable, if I just wanted to make a single bar chart. But that doesn't enable me to make a small multiples bar chart, right? Because I can't do it for a single variable, because when you're doing faceting, when you're using small multiples, it has to be a single variable. So what we actually do, and the reason we do this is because you're hopefully realizing that plotting using untidy data doesn't work within the philosophy of ggplot. So if I tidy my data using the code that I used in the previous section of the course, I end up with this German speakers tidy data frame. And you can see now I have 3 variables: state, year, number, right? Now I can do this. I've changed x, I've added x equals number, right? So it's this single variable. It's not spread over 3 variables. And year is just its own variable as well. So then I can do facet wrap year. So I'm telling it, okay, cool, we're going to make a bar chart with, on the y, we'll have the state. So each state, it shows up on our y-axis. And then on the x-axis, that will be the number of German speakers in that particular state. We use geomcall, which is a way to make bar charts. And then we use facet wrap to say, make one for 2017, make one for 2018, make one for 2019, right? So if you're having trouble plotting your data and you're like, the structure of it just isn't working, think about whether your data is tidy, because it may not be. So that's one of the main reasons I wanted to go through tidying data in the last section, was not just in terms of thinking about it to make your analysis easier, but it also makes it easier in terms of visualization. All right, let me stop my recording. Okay. The next section is about highlighting. I'm actually going to begin by piping data into ggplot, because I think that's a useful thing to be able to do, and it's not something I mentioned in the fundamentals of our course. All right. Okay. All right, we're going to begin by highlighting, talking about ways that you can highlight data. No, not highlight data, or highlight findings. All right, we're going to begin by talking about highlighting. One of the single most effective ways. We're going to begin by talking about highlighting. One of the best ways to make your data visualization communicate effectively is by helping the reader to highlight some of the important findings within it. Before I actually get into highlighting, though, I want to just show you a nice technique that will make things easier for you as you work with ggplot. You can actually pipe data into ggplot. I'm actually wondering, should I? I need to reorder this because the highlight section should come after the piping data in. All right, let me knit this. Refresh this. Messed up one thing. Okay. Okay. I want to just show you one other little trick before we actually get into some of the specifics of using ggplot. Sorry, there's something weird going outside my house. Let me start that again. I want to just share one more useful tip for working with ggplot before we get into some of the specifics of the data visualization section. You can actually pipe data into ggplot, and here's what I mean. First, we're going to load our data. If you recall from the data wrangling and analysis section, we went through a whole series of steps to clean and to tidy our data, and then we saved it as an RDS file. We can now load that data using, for example, this code. 3rd grade math proficiency, and then the assignment operator read underscore RDS, and then in quotes the path of the file, which is where I saved it last time. So read underscore RDS is how we're going to read in our RDS files. Oh boy, that looks funky. I don't know why I'm getting such weird rendering often of how it displays. Yeah, there we go. All right, so let's take a look at this. So our 3rd grade math proficiency data frame has school, school ID, district, district ID, percent proficient, and year. All right. We can actually pipe this data into ggplot, and it becomes particularly effective when we want to, for example, do some filtering beforehand. So I could say, for example, if I only want to look at Baker School District 5J, for some reason in Oregon they put these weird like 5J, 1J things at the end of district names. I don't know why. In any case, if we want to do filter district equals Baker SD 5J, and then we also want to only include 2018, 2019 data, we could do it like that. And that would display, that's the results of what we would get. But I can actually pipe this directly into ggplot. So you can see now, for example, I use the pipe here, and now I'm switching to ggplot. So I am, I don't actually know why I didn't, hold on, let me just highlight that chord flip as well. All right, this should, yep. I can now pipe this directly. Wait, I did Portland here. What am I doing? Sorry. Let me go back and make this consistent. try this again. Okay. One thing we can do is we can pipe data directly into ggplot. So just for example, if I start with my 3rd grade math proficiency data, let's say I only want to see data for 2018-2019, and I only want to see data from Portland School District. I don't know why in Oregon they add this 1J, 5J thing at the end of school district names. No idea what it means. In any case, if I run this code, I gotta refresh that. I don't know why it's displaying so weird. Okay. So if I run this code, here's what I end up with. You can see I have only schools now from Portland and only data from 2018, 2019. Okay. Now I can pipe this directly into ggplot, right? You're probably used to right here having data equals 3rd grade math proficiency. But if we want to do it in this way, if we do it in this way and only show, for example, 2018 data for Portland School District, it's much more efficient to do it in this way, piping it into ggplot as opposed to, for example, making a new data frame called Portland Math 3rd grade math proficiency 2018-2019, right? We can do it in this way, and we just drop the data equals here. We don't have to put that because whatever is piped in is assumed to be the data. Okay. Then I could make a bar chart that just shows the level of math proficiency for all schools in Portland in 2018-2019. You can see that's what I end up with. Just want to go back here for 1 second and highlight one other thing. You're going to notice here, I did not say mapping equals AES. I did that throughout my fundamentals of R course, but I'm not going to do it very much here. I may do it occasionally. For the most part, I don't do that, and most people don't do that when they write R code, when they write ggplot code. It's not necessary. I do that when I'm teaching people just starting out. But at this point, because you are a little bit more advanced, I want you to see code written in a way that you're likely to see it from others. So that's what's going on there. Also, if I ever don't include x equals and y equals, know that those are not actually technically necessary either. The first variable in our aesthetic properties is assumed to be the x variable, and the second one is assumed to be the y. All of the other aesthetic properties we do have to list explicitly, but those two we can leave unnamed. And I may do that throughout the rest of this course. All right, here's what I want you to do. I want you to make a new R Markdown document. You have done everything so far in an R script file, but I actually want you to switch to R Markdown because to make this visualization that we're going to make for this section of the course, and then in the next section where we're doing R Markdown, I want you to be working in R Markdown. I want you to then create a data frame called enrollment by race ethnicity by reading in your race ethnicity data from the data wrangling and analysis section using the read_rds function. And just so you know, that read_rds function comes from the readr package, so you are going to need to load the tidyverse before you actually use that function. If you don't load the tidyverse, it will not work. Then I want you to pipe that data into a bar chart that shows the breakdown of race ethnicity among students in Beaverton School District 48J in 2018-2019. Okay, go for it. All right. I'm just looking, well, here, I'll bring this over here. Okay, I'm going to close this. All right, I'm going to record the solution video for this. Okay. Let me just remind myself. Whoops, did I close? Oops, sorry, I think I closed that here, which I did not intend to do. Okay. You know, and I'm actually just thinking, come on. Just let me look through the slides, because I've actually done a bunch of this where it's it's okay. Okay. All right, I am going to begin by making a new R Markdown document. I'll just call this report on diversity in Oregon schools. Just leave it as an HTML file. I'm going to go ahead and save this right now. Just call this Oregon Schools Diversity Report. All right. I'm going to do a few things. First, I always just go in. I'm going to delete that. I'm going to change the options here. I'll set echo equals false. I'll do that for now. Let me start add another code chunk, and I'll do a library tidyverse. Tidyverse. I think that's all I need for now. I might need to add packages as I go along. So I am now going to import my data, and it was, so I'll do enrollment by race ethnicity, and I'm going to do read RDS, and I just need to put the path. So it's data enrollment, whoops, by race ethnicity dot RDS. All right, let me check that out. Cool. I've got that here. And then the next thing I asked you to do was to pipe this in to a bar chart to show the diversity at Beaverton schools in 2018. Actually, let me check it out in 2018, 2019. So I'm going to just copy the name of the district. So I'll do a filter district equals Beaverton. Oops, I don't actually want to run it yet. But I can see that worked. So now I have just the district here. And I want to do filter year equals 2018, 2019. Run that. Cool. So now you can see I have the race ethnicity groups just for this year. So I'm going to pipe this in here, ggplot. I don't need to list any data here, right? Because the data is already piped in. So I'll do AES, and I can do X equals, I'm just thinking about how I'm going to do this. I'll put % of total at school. My X, I'll put race ethnicity on my Y. And then I'm going to do plus, and it's confusing because you might actually want to do a pipe there, but once you, in a single pipeline, once you switch to ggplot, you do have to then do the plus. So I'll do geom_call and let me run that. There we go. I have a chart that shows race ethnicity in Beaverton School District in 2018, 2019. You can see white students are, looks like a little under, well, I could also look back here, but a little under 50%, followed by Hispanic, Latino, Asian, and some other folks. All right, there we go. Okay, let me stop recording. Put data into ggplot. Give me just a second. Have a little snack, keep myself going. All right. So I'm beginning actually by just talking about reordering plots to put largest groups at the top, which is a really common technique within data visualization. And I'm doing it by using the reorder function within ggplot. Then I'm also showing folks how they could do that using the FCT reorder from the forcats package. I don't actually want to go into talking about forcats and factors in any great depth. So I really just want to kind of provide people a couple options here, and then I'll, in the Learn More section, I'll link to information on that package. All right. All right, let me go back here. Let's return now to the idea of highlighting, which is the first the first kind of best practice that we can use to make our data visualization communicate effectively. The first thing we're going to do in order to highlight our findings is to reorder our plots. And this is effective throughout the highlighting section. The main goal is really going to be to help the consumer of your visualization understand what's going on, not force them to dig around themselves for that finding, right? You have spent all the time doing the analysis, creating the visualization. You're the expert in what's going on. So really help your reader, help the consumer understand what's going on. There are a couple ways that we can reorder our plots. So this is exactly the same as what I showed before, making that bar chart. But you can see I've highlighted one line, and I'm using the reorder function. So before it just had x equals school. Now I've changed it so it says x equals reorder. And then within parentheses, what's the first argument is the variable that I want to reorder. So I want to reorder the school variable, and I want to reorder it by the % proficient variable. So let me show you what happens when I do that. Now it's ordered by, with the school at the top, Le Monde French Immersion Public Charter School, has the highest percentage of third grade math proficient students of any schools in Portland public schools, right? And so I've done that again by using this reorder function. So instead of just listing schools in alphabetical order, they're now listed in order by % proficiency, okay? That's how we can do it within our ggplot function. Another way to do it is using a function from the forcats package. It's fct_reorder. And this enables us to reorder. It's going to be really similar to the reorder function, but we're going to actually do it in a line before we actually get to the ggplot, right? You can see I've added this mutate line here. When I use fct reorder, what it does is it converts school into a factor. It had been a character variable. If I were to look at it, I would see that it's now a factor. And while I don't want to get into all the details about what factors are, because it's way too complex to discuss in this section of the course, or indeed in this course at all, just know that by doing this, we'll now reorder so that school will be reordered by % proficient, and that underlying structure will carry over here into the ggplot section. So when I run ggplot, I'll actually get the same thing, right? Same exact thing. So now what I want you to do is I want you to make a bar chart that shows race, ethnicity in Beaverton, same thing. And I want you to filter to only include 2018 and Beaverton, but then do the following. I want you to use the reorder function to make a bar chart that shows the % of race ethnicity groups in descending order. And then I want you to use mutate and fct reorder to reorder the race ethnicity groups in the same way that I did. Whoops. Okay. All right, I'm going to record the solution section. Just move this down a little. Okay, so I have my bar chart from before that shows, you can see in descending order, race ethnicity on my y-axis. So first thing I want to do is I want to use the reorder function. So I'm going to do reorder race ethnicity, and then the next variable that I'm going to put here is the one I want it reordered by. So I want it reordered by % of total at school. I'm going to need to add an extra close parentheses, and when I run that, you can see now it's ordered by whichever group is the largest. Okay. So that's how I did it that way. Let me undo that, so go back to how it was before. The other way I wanted you to do it was using mutate here. So here what we're doing is we're actually changing the data type to a factor using fct reorder, which comes from the forcats package, which is part of the tidyverse, so we don't need to load it explicitly because we've already done up here library tidyverse. You can even see, for example, forcats is right there. So fct reorder, and I'm saying I want to reorder the race ethnicity variable, and I want to do it in order by % of total at school. So I'm going to run that. and now I get the same thing. Oh, shoot. I think I just realized that I was not recording any of that. Awesome. Okay, let me go back and re-record that. All right, now that we've learned about piping data into, wait, hold on, I didn't start my recording. All right, now that we've learned how to pipe our data into ggplot, let's begin by All right, now that we have piped our data into ggplot, let's begin by thinking about some of these principles and how we can apply them to make our data visualizations communicate more effectively. The first one is highlighting. And it's important to highlight your findings in your data visualization because you are the expert. You're the one who has done the analysis. You're the one who has created the visualization. Don't make your reader search for the findings. Really highlight them so your reader can see what they need to see. The first way we're going to do this is by reordering our plots to highlight findings. So let me give you an example of what I mean. When I did my plot before, if you recall, it just had all of the schools. In fact, I can even flip back and remind you. It just had all the schools in descending order, in descending alphabetical order, right? Because all I did was x equals school. But, flip back here, if I want to reorder these to show the schools with the highest level of math proficiency at the top, I can do that by first using the reorder function. So I say instead of x equals school, x equals reorder school, and then comma, % proficient. So in other words, I want to reorder the school variable by % proficient. So when I run this, now you can see it's ordered by % proficient. So for example, Le Mans French Immersion Public Charter School is at the top because they're the highest percentage of students at that school who are proficient in math in 3rd grade in all of Portland Public Schools, right? Another way to do this is actually working with our data before we even get to ggplot. So you can see I've added a line here. And so I'm using mutate school. So in other words, I'm changing the school variable, and then I'm doing equals FCT reorder. This is a function from the forcats package, which we get access to because forcats is one of the packages that is loaded when we type library tidyverse. What it does is it converts our variable that was a character variable into what's called a factor. Now, factors are more complex than we have time to discuss in this course, but I will post links to some materials that will help you to learn a bit more about them. For our purposes, what we need to know here is that using this FCT reorder, we can reorder the school variable by % proficient. And so then when I get down to ggplot, when I get down to here, I no longer have to put that reorder again because I've actually changed the school variable so that it already kind of has that order embedded within the variable itself. Now when I run it, you see I get the exact same thing that I got when I did the reorder within ggplot. Okay. So for your turn, I want you to make a bar chart that shows race ethnicity again in Beaverton. Only use 2018-2019 data and only use Beaverton. Then I want you to do the following. Use the reorder function to make a bar chart that orders the race ethnicity groups in descending order. And I should say in descending order by which has the highest percentage. And then do the same thing using the mutate FCT reorder structure that I showed you. let me rerun this again and do the solution. All right, so now we're looking at our code from before. You can see this is where we were. We threw in a couple filters here before we got to ggplot. But now I want to reorder this race ethnicity variable by percent of total at school. So the highest percentage shows up at the top. So I'll do reorder race ethnicity and then percent of total at school. I'm going to need to add another close parentheses because I had an open one right there. Can run that. And you can see now I've got it ordered in descending order by the race ethnicity group that is the highest, which in this case is white. Okay. All right, I'm going to undo that, go back to how it was, race ethnicity. And now I'm going to do the same thing using the mutate FCT reorder. So I'm mutating my school variable. That's the one I want to change. And I'm going to do FCT reorder. I want to reorder. I want school to be a factor that is starting with the school variable. And then I want that to be reordered by percent of total at school. Now, one mistake you might make is you might do plus, and it would say, wait, that's not right. Because you're still working, you haven't gotten to ggplot yet. You haven't made that transition into the world of ggplot. We're still in, well, dplyr up here. We need our pipe. Run that. Why is that not working? School is... What am I doing wrong here? FCT reordered. I didn't like order. School not found. Oh, duh. I'm doing school, not race ethnicity. All right, let me go back to here. All right, let me now show the same thing using the mutate race ethnicity. All right, let me show the same thing using the mutate FCT reorder structure. So I'm going to add a line here, and I'm going to say mutate race ethnicity equals FCT reorder, and I'm going to start with the race ethnicity variable. So in other words, when I'm making this not new race ethnicity variable, when I'm overwriting it with itself, I'm saying start with this variable and reorder it by percent of total at school. Run that. And now you can see I get the exact same thing, right? It's ordered by race ethnicity. All right, let me stop. And I think I'm actually probably going to stop there. Yeah, because it's going to get a little... Yeah, I'll actually stop there. Hold on one second. Yeah, so I will be back tomorrow, same time, to do some additional work. Thanks to those of you who